Thank you for your introduction. Good morning, I am Federica Grossi and my tutor is Professor Zanasi. The title of my research activity is Dynamic Modeling and Control of Complex Physical Systems. In this presentation I will show you the activity carried out during this year. I work always with power-oriented graphs technique, that is the modeling technique I use in order to give models of complex physical systems. In particular, during this year, I dealt with 3 topics. The first one is the modeling of multi-phase asynchronous motors. The second is a model of an internal combustion engine. And last one is a comparison and integration with the POG technique and another modeling technique named energetic macroscopic representation. Just to remember what power-oriented graphs are, they are a sort of block diagrams based on 2 main blocks that are the elaboration block and the connection block. So all the block scheme you will see in this presentation are made using this technique. The modeling of multi-phase asynchronous motors started from a Lagrangian approach. So, starting from the Lagrangian function and using the Lagrange equation, it is possible to write the differential equations of the motor dynamics that are shown over there. Then we consider some transformations, mathematical transformations, in order to have a model written in a different way in order to put in evidence and highlight some properties. The POG scheme of the motor is represented here, and there is a direct correspondence between the POG scheme and the state space equations of the system. For these asynchronous motors, it is possible to obtain an innovative expression of the phase vector and of the mechanical torque that is a little bit different of what you find usually in literature. And it was possible also to find an expression for the maximal torque. All these models have been put into MATLAB Simulink software, and here some simulation results are presented. For example, the mechanical torque and the numerical reconstruction of the phase vector, that is the vector tying the current and voltages vector. The second topic I want to show you is the model of an internal combustion engine. I made this work in collaboration with the Università del Sannio, and in particular with ELASIS, that is the Fiat Center of Research. The goal of this work was to provide an internal combustion engine model using a different approach. It is to say, they wanted to eliminate the space dynamics while preserving the time dynamics. In order to do this, I wrote an equivalent electric circuit, because there is a direct correspondence in terms of topology between different energetic domains. So this is the POG scheme corresponding to the equivalent electric circuit, and the POG scheme is comprehends also the part with the piston rod of the motor. The main benefit of this approach is the possibility of writing the differential equations of the whole system. It is to say, not each equations, but the whole state space equations. So here there are some mathematical details of the model and some simulation results that have been carried out using MATLAB Simulink, and also some experiments with real engine have been made. The last topic is a comparison between POG and EMR formalism, and I carried out this work during my period abroad at the University of Science and Technologies of Lille in France. As we use the POG technique, they use the energetic macroscopic representation formalism. So, considering an application that was the model of an electric vehicle with tire-soil interaction, I realized this model in the two different ways, using the two different techniques. So I proposed a comparison and an integration between these two techniques. In the upper part we see the POG scheme, and in the lower part the EMR scheme. There is a correspondence between this scheme, and we can see the correspondence between different blocks. In particular, the EMR provides a methodology to obtain a structure for the control. In this example, we wanted to control the speed of the vehicle, so through inversion rules, it has been possible to control the velocity of the vehicle. Just a summary of the comparison between these two techniques concerning the main aspects. The objective of these two techniques is different. So POG are focused on the analysis of the systems, while the EMR is focused on the control structure we want to provide. The number of basic elements is only 2 for POG, while it is very high for the EMR, so it's not so easy readable. For simulation, POG can be directly translated into Simulink schemes, while EMR need a Simulink dedicated library. And finally, for the POG, there is no methodology in order to provide the control structure, but it is based on literature rules based on state space expression, and the EMR provides a methodology in order to obtain a maximal control structure for the system. So my work is always focused on the study and analysis of the power-oriented graphs technique, and in particular I focused on the modeling of multi-phase asynchronous motors, of an internal combustion engine, and on an electric vehicle. This last topic has been developed using 2 different techniques, and a comparison and integration between these techniques have been made. Here are my publications. Thank you for your attention. There is some question. In France. Yes. Speak in French? Yeah. Yes, it was the last topic. Last topic, it was related to my period abroad. Okay. Okay, thank you.